This is going to be our video for Unit 1, Day 3. What we're going to be talking about today is fractions. So working with fractions the same way the last 2 days we've been working with whole numbers. So we're going to learn to add, subtract, multiply, and divide fractions just like we did with our whole numbers the last 2 days. So the first part of this, we're just going to go through a little bit of vocabulary. So first thing is there's a lot of different words we use to describe fractions. So fraction, another word for fraction is a ratio. These words are used interchangeably a lot in math, but all ratio means is fraction. So anytime you see ratio, just think fraction. That's what that means. Fractions are also called rational numbers. Any number that can be written as a fraction is called a rational number. If it can't be written as a fraction, it's an irrational number. You also see this word rational when we get into algebra and we start talking about algebraic expressions that have fractions in them are called rational expressions. Right, so we see that same root word ratio, right, pops up in all of them. That's what tells you anytime you see that word ratio, working with fractions. So this example right here, you've seen a fraction before, you know what a fraction is. This is what it looks like. It's one number over top of another number. So remember that this sound right here means division. Right, that bar in the middle means dividing. So that 3 over 4, we're talking about 3 parts out of 4, 3 divided by 4. So top of fraction, we call that the numerator. And bottom of fraction, we call it denominator. So again, we'll work towards using these vocabulary terms, numerator and denominator, instead of saying top and bottom, but a lot of times I'll use them interchangeably, just because it's faster to say top and bottom versus numerator and denominator. Alright, so jumping right into working with fractions. So we know what a fraction is, we know the vocabulary. How do we work with them? How do we add them? How do we subtract them, multiply, and divide? So we're going to start with adding and subtracting. These follow the same process. Anytime we add or subtract fractions, the denominators have to be the same. So what we call this is a common denominator. Alright, so we want to do when we add fractions is see that these are out of the same number of parts. The denominator is the same. So the way we find a common denominator is we look for a number that's a multiple of both denominators. So both denominators will multiply up to that number, and we're going to multiply to get up to that number. And the biggest mistake is make sure whatever you multiply the denominator by to get to that common denominator, multiply the numerator by the same number. So for this, you can use your calculator sheet to help you out, see all the multiples, different numbers. Here I have two denominators in the problem. My denominators are 2 and 10. What I need to find is a number that is a multiple of both 2 and 10. Alright, so I think about the multiples of 2. I've got 2, 4, 6. 2, 4, 6, 8, 10. That'd be everything on the calculator sheet. Then we start listing the multiples of 10. Alright, we got 10, 20, 30, 40, right, we keep going. When you do this for two numbers, what you're looking for is the first number where they're the same. Alright, so here I've got a common multiple. Alright, 10 and 10. So that tells me that 10 is going to be my common denominator. Any number that's a multiple of both these numbers will work as a common denominator, but you always want to try and use the lowest common denominator, so the smallest number that works, smallest number that is a multiple of both denominators. So again, the way we change the denominator is we're going to multiply. Alright, so our common denominator is going to be 10, so I have to think, what do I multiply 2 by to get up to 10? Got to multiply by 5. Alright, so I'm going to multiply the top of that fraction by the same thing. In this case, we don't have to actually multiply 10 by anything, but in some problems we'll have to multiply. In this case, all we're really doing is multiplying by 1. Alright, so write out what I have now. I have two fractions over the same denominator. I have 5 over 10 and 4 over 10. Alright, when we add these, what we're thinking about is we're adding pieces out of 10. So I have 5 pieces out of 10, I'm adding 4 pieces out of 10. That gives me 9 pieces out of 10. Alright, so you notice that we're only adding the numerators once we have the common denominator. So all these problems down here are for you to practice, so you can follow those same kind of steps, look for numbers that are multiple of both two denominators, find the common denominator, and then add them up. Now we do subtraction, it's the same process, only difference is we're going to subtract those numerators instead of adding. Just the one note here at the bottom of the page. If you're having trouble finding the common denominator, you can always multiply the two denominators in the problem to find the common denominator. Alright, so you can always multiply the two denominators to find the common denominator. This won't always necessarily be your lowest common denominator, though. You want to make sure, whenever you can, try and find that least common denominator, so you're just working with smaller and easier numbers. So now we've talked about adding and subtracting fractions. Now we're going to go through other two operations. We're going to multiply and we're going to divide fractions. Alright, so we multiply fractions. It's very easy. All we do is we just multiply straight across the top and straight across the bottom. Alright, so here we have 6 over 7 times 2 over 3. Alright, so I'll do is multiply 6 by 2, and that's 12, 7 by 3, and that's 21. And there we go, that's our answer. Now, one thing you're also going to have to do when we get to the test is you're going to have to simplify. So you're going to have to look at this fraction and see if you can simplify it at all. Are there any common factors you can take out? Any numbers that multiply up to both 12 and 21 that we can get rid of? So in this case, we can take out is 3, because 3 times 4 is 12, and 3 times 7 is 21. So we can get rid of that 3, and this would be the same as just writing the fraction 4 over 7. Alright, this is called simplifying. So the directions say simplify or fraction answers, you have to put the lowest equivalent fraction you can find. So another way we can do this, and this is kind of a shortcut, is called cross cancellation. So cross cancellation is where we actually simplify before we multiply. So we take out those common factors ahead of time and then multiply. So if we use the same problem here, what I can do is look for any opposite pair, so numerator and denominator, on either fraction that will simplify with each other. So I see where I have 6 and I have 3, right? I know that the fraction 6 over 3 equals 2. So what I can do is I can cross each one of these off, replace the 6 with a 2, replace the 3 with a 1. And now multiply using those new numbers. So 2 times 2, 4, 7 times 1, 7. What we see is that we get the same answer either way. So whichever way works for you, do it that way. On the board, typically when I'm doing problems, I'll use cross cancellation so I can work with easier numbers. If you take those factors out at the beginning, it's easier to find common factors between 6 and 3 than it is to find them between 12 and 21. So dividing fractions is going to be very similar to multiplying fractions. The only difference is we have to flip our second fraction. So we have to invert it before we multiply. Alright, so this is also called, flipping is also called reciprocal of a number. Alright, so we flip a number, it's called the reciprocal. It's also called the multiplicative inverse. Alright, which means if we multiply them together, it will multiply to 1. So once we flip that second fraction, everything that we talked about with multiplication, simplifying, canceling out common factors, cross cancellation, that's all still going to be the same. What we're going to do is flip this fraction first. So in the example, 1 over 6 is the fraction we're dividing by. So this will be the same as 3 over 4. Now multiply by 6 over 1. Alright, now it's just like the example we did with multiplication. So here we can look for cross cancellation. I have 6 and 4, both even numbers, so I can take out a factor of 2. This would be 3 2's, and this would be 2 2's. And I can multiply these numbers. 3 by 3 is 9, and 2 times 1 is 2. That's all the rest of these problems on this page. You can go through, practice these on your own. Any questions, you can ask me when you get back to class. We can go through anything you want to on this sheet. So next thing we're going to look at is when we have mixed numbers instead of fractions. So instead of just one fraction, we have a whole number and a fraction together. So to work with these, what we're going to do is turn them into improper fractions. Alright, and all that means is that the numerator is larger than the denominator. So in terms of the valued number, means it's greater than 1. And that's all that means. There's nothing wrong with the improper fraction. You can leave a lot of your answers as improper fractions. We just call it improper to mean that the numerator is larger than denominator. So we say proper fraction if it's less than 1. So when we want to change it into an improper fraction, what we're really thinking about is addition. Right? We're adding two fractions. So any whole number is like a fraction over 1. Right, and if we want to add these together, we're going to have a common denominator. So here, our common denominator would be 3. Alright, so we follow everything just like we did on the addition page. We change 2 over 1 would be 6 over 3. We add up our numerator 6 and 2, and we get 8 over 3 as our improper fraction. Alright, this works the same way if we have a negative number. Alright, Alright, everything is the same. Alright, we don't do anything different because it's negative. We do the same thing. So we'll start by working with the 7. Alright, again, it's going to be the same process. We're going to have to change denominator, make a common denominator. Here we're going to use 5. So we'll have is 35 over 5 plus 1 over 5. So that would be 36 over 5. And now the last step is we'll throw the negative back in there. There's also a shortcut you can do to make this process go a little faster. Alright, so what we can do is we can take the whole number, multiply it by the denominator, and then add the numerator. So in this case, what I'll be doing is multiply 7 by 5. That's 35. I'm going to take that 35 and add that 4 that was already on top, and I get 39. Alright, so then my improper fraction would be 39 over 5. So this is just a shortcut way of doing it. It's a little bit easier than going through that change denominator every time. This is the same steps, we're just doing it a little bit quicker. If you look at the pattern up here, we're always multiplying this 1 by whatever this number is. Right? Same thing over here. Right, so you notice that pattern, and we can use that pattern to make a shortcut. So last thing we're going to do is just go through our operations with mixed numbers. So anytime we're working with mixed numbers, first thing we're going to do is turn them into improper fractions, and then everything we're going to do from there is going to be just like we did with fractions. So same way we add and subtract fractions, same way we multiply and divide fractions. But our first step, if it's mixed numbers, is to turn them into fractions. So here I'm going to use my shortcut. So I'm going to turn this into an improper fraction by multiplying 1 by 5 and adding the 2. So that would be 7 over 5. Same thing with the second one. 6 times 10, I'm going to be adding 1. So that'd be 61 over 10. Alright, we see this is a fraction addition problem. Alright, what do we have to do to add fractions together? We need a common denominator. Alright, anytime you see fraction addition or subtraction, you should always think common denominator. So here we're looking for a multiple of both 5 and 10. 10 will actually work here. So 10 be 5 times 2, and it's 10 times 1. So we're going to multiply both the top and bottom of this fraction by 2. So we'll have 14 over 10 plus 61 over 10. And then we're going to follow our same process for addition, where we're just going to be adding the tops of these numbers, adding the numerators. So 14 plus 61 makes 75 over 10. Right, and again, we can simplify if we see that these numbers have any common factors. So 75 ends in 5, 10 ends in 0. That means they're both divisible by 5. So 75 would be 15 5s, and 10 would be 2 5s. This will simplify to 15 over 2. Over here on the right side, the multiplication, again, it's going to work the same way. We just have to turn it into a fraction first. So we'll go 2 times 2 plus 1. Let's make 5 over 2. 2 times 3 plus 2 would be 8 over 3. Right now, this is fraction multiplication, so we can look for things like cross cancellation. So in this case, I can cancel 8 over 2 is the same thing as 4 over 1. And I can multiply these numbers. 5 times 4. 5 times 4 is 20. And 1 times 3 is 3. Alright, if we did division problem, again, you'd follow the same process. You'd first turn it into two fractions, then you take that second fraction, flip it over, and multiply across the top and bottom. Alright, so there's a lot of problems on this page. Make sure you practice this. There's going to be a quiz tomorrow on this, working with the fractions. Everything we've done the first 3 days, and especially this focus on the mixed numbers, tends to be the hardest part. So make sure you do this practice. Make sure you're getting that work in so you can be comfortable with it before the quiz.